Welcome back, everyone. This is part 3 of LLM Intuitions, and it's called To Write is to Read. So let's just recap what we looked at last time. What we saw was that neural networks and deep learning helped us in some really big ways. Prior to these concepts, we were kind of trapped in this tabular worldview of data that was preventing us from reading the text in order correctly. And so neural networks, owing to their flexibility, helped us break out of a tabular view of the data. And they also helped us transfer knowledge learned on one task to another task. And this was a really big deal. And the example we saw was the word to book algorithm, where we played fill in the blank on a bunch of web data. We didn't have to pay any data annotators to label stuff for us or anything. We just downloaded web data, corrupted it, and kind of created our own quasi-labeled data set that way, and trained a neural network to play fill in the blank. And as a byproduct of that, we learned these deep numeric representations of our tokens, of our words. So rather than just seeing the RNN didn't just have to see token 3, it could actually see this deeper numerical representation of the meaning of token 3. So then we saw how RNNs plus word embeddings, which basically meant sequentially reading tokens that you understand the meaning of and remembering what you just read, that gave us a pretty solid approximation of reading, and it improved the state of the art a lot. And that puts us roughly in the 2013 to 2016 timeframe. But so far, all of our attention has been focused just on reading and understanding texts. Seems like we have some pretty good tools for that now. But what about writing? This whole series about LLMs, and they're generative and their output is just amazing. So obviously writing is a very important part of that. Let's start to get some intuition for what it looks like to write. So this probably sounds trite, but I think it's true both for humans and machines. You must be able to read in order to write, or controversially, if you can't read, then you can't write. And so reading, the reason we focused on that so much is it's so core to writing. In some sense, adding an ability to write is just an incremental addition to our fundamental reading architecture. So let's look at our reading architecture again. So we have our blue box representing the RNN. It's already scanned over hi, comma, space, thanks. Of course, it would have seen the token identifiers that had then been passed through their embedding functions to get deeper numerical representations, but it effectively read that and updated its memory, and it outputs its current understanding, sort of a soft numerical understanding of what it's just read. Well, then in order to write, all we need to do is attach a predict functionality represented by this green box. That's essentially going to be another machine learning classifier in the same way that machine learning can classify images as cats or dogs. What it's going to do is it's going to, instead of taking an images input, it's going to take the current understanding out of the reader module. And what it's going to classify or choose is it's going to pick across the entire vocab of tokens, essentially which one it thinks is the most likely to come next. So let's say in this case, it thinks the most likely next token is the word for. So the predict module outputs for. Well, then that gets added on to the end of the sequence that we're reading. And then it gets passed through the reader to update our current understanding. So as you can see, writing is just an extension of reading, where the predict module introduces additional new tokens one at a time that get passed through the reader so that we can kind of update our understanding of what we've read. And that understanding goes into the predict module again, and that just happens progressively. This is maybe most easily visualized with our feature Quiq Compose, which is a predictive typing feature learned on our tenants' data, where we kind of learn the language of their contact center and help them type it, similar to what you see in Google Docs, but much more specific to a given company's domain. So in this case, hi, comma, space, thanks have already been typed. So we have to tokenize those, encode them, and then pass them one at a time through the RNN and get the embedding for each one while we do that. At that point, we've read hi, thanks, and now we enter the prediction phase. So we're going to call predict, which outputs 4, and great. So we predicted 4, so let's go ahead and read it and then repeat. And as we repeat, we can unroll a complete generated text. So for contacting Quicksilver, my name is Quiq Hosting. So that's pretty much what writing looks like, is attaching this predict function and predicting the next token one at a time. And it's this sort of behavior that really makes a model generative. When you're hearing about generative AI, this is sort of the nuts and bolts that make the model generative. And another term you might hear for it is autoregressive. It's maybe a bit more on the techie side. Just a little bit more on predicting the next token. So like I said, we kind of train a classifier like we do in other machine learning contexts, and we can assign probabilities to all of the tokens in our vocab. We assign those probabilities based on the current understanding. That's sort of the input, in the same way that the image is an input to an image classifier. Our current understanding of what we've read is the input to the prediction module that's going to classify or predict the next token, but it actually assigns probabilities to all the tokens it knows about. And for those of you who are maybe a bit more, computer science savvy, once you have the probabilities for all these tokens, you could employ different search algorithms for how you pick them. Now, the most obvious is just called greedy search, where you're going to take the token with the highest probability and select that and feed it right back into the model. But oftentimes, it's beneficial to try some more advanced search algorithms, similar to like when you're playing games and stuff. Sometimes making the most greedily obvious choice doesn't pay off in the long run. And so those same sorts of search algorithms are used to generate the completion coming out of a generative model, like an LLM. There's a beam search, which is like greedy search, but instead of just taking the single most likely thing, you keep track of, say, the 3 most likely things and feed all 3 of those back. It's kind of like you read the text and you now see the 3 most likely completions. So now kind of make 3 copies of your text, assuming you added each of the 3 most likely words, and then see what their respective most likely words are. So you're kind of considering 3 futures. And these are just different forms of look ahead to make the search smarter, to potentially produce a better text completion at the end. So that's just a little bit more on the predict functionality. The search algorithms add a lot of lift and then get a little complicated. If you've looked at OpenAI's ChatGPT APIs, when you call it, there's a lot of options, and a lot of those options are basically controlling how the search algorithm behaves in terms of how many possible futures you want it to consider, or how creative you want it to be, things like that. It all has to do with search, but fundamentally it comes back to, I'm going to go back to the last slide now, that you have this module that can take kind of the current understanding of what you've read, and based on what it's learned during training, that it can assign probabilities to all of the tokens that you know about in your vocab. That's the fundamental building block. And then you can do all kinds of fancy search algorithms across that to pick tokens. And whenever you pick a token, you have to then read it so you can update your current understanding and get to the next step. And I think that's it for this video. Yep, okay, sneak peek on next time. We'll be looking at part 4, and we'll be talking about transformers. So once again, thank you for checking out my video.